Today, we're diving deep into one of the greatest marvels of modern engineering, the construction of a brand new generation of absolutely colossal, eco-friendly container ships. All right, to get us started, I have a quick question for you, just to set the scale. What do you think is as tall as a six-story building and weighs over 2,000 tons? I mean, maybe a factory? A small skyscraper? The answer? The engine of a single container ship. Yeah. And you know what? That's not even the most impressive part. That incredible machine is just one single piece of a floating city of steel that is completely changing the face of global trade. Now, to understand why these ships are so incredibly important, we need to zoom out and look at the bigger picture. We are living in a new age of giants, and it's all being driven by a revolution in global shipping. Just think about this staggering number for a second. A full 90% of all international trade travels by sea. Everything from the tiniest little needle to the biggest car gets transported on these massive vessels. Right now, as we speak, there are nearly 40,000 cargo ships sailing the world's oceans. For decades, the name of the game was simple: build bigger and bigger ships. But, well, we've kind of hit a physical limit. If they get any larger, they won't fit through crucial waterways like the Suez and Panama canals. So, the new race, the real engineering challenge of our time, it isn't about size anymore. It's about efficiency and sustainability. So just how massive are these new eco-friendly titans? Let's break down the anatomy of one of these mega ships. And I'll tell you, the numbers are almost hard to wrap your head around.
First up, its length. The ship measures 400 meters from bow to stern. Now, to put that into perspective for you, you'd need to lay 4 football fields end to end just to match its length.
Now for the weight, and get this. This is its empty weight, without a single container on board. A mind-boggling 70,000 tons. That's the same mass as 7 Eiffel Towers, or, if you prefer, 11,500 African elephants. And what can it carry? A grand total of 23,112 standard shipping containers. If you were to line all of those up, one after another, you'd create a chain stretching for 150 kilometers. Building something on this kind of monumental scale, well, it requires an equally monumental plan. You can't just build it piece by piece in a dry dock. The solution is ingenious. You build it with giant prefabricated Legos. And the pressure on the shipyard was just immense. The order wasn't for one of these ships, but for 9 of them. And they had to be delivered in just 2 years, a time frame that would be considered tight for just a single one of these vessels. To hit this impossible deadline, they perfected what's called the modular method. The ship is basically broken down into these massive blocks. These blocks, some as big as buildings, are built at the same time all across the shipyard, already complete with internal pipes and wiring. And then they're just lifted into place by these colossal cranes. The whole process starts by cutting over 12,000 individual steel sheets with a special laser beam that reaches 18,000 degrees Celsius. I mean, this is just brilliant. It shows the power we're talking about. That's 3 times hotter than the surface of the sun, and it slices through steel like butter. Once the pieces are cut, they all have to be welded together. The total length of welding on a single ship is 1,250 kilometers. That's a continuous weld long enough to stretch from Karachi all the way to Lahore, and every single centimeter is inspected, because you know the unforgiving waves of the ocean will exploit any weakness. But as impressive as the construction is, the true revolution lies right at the heart of the ship: its fuel and its engine. This is what's building a whole new future for shipping. You see, this ship is designed to run on liquefied natural gas, or LNG, and this is an absolute environmental game changer. Compared to the old traditional fuel, LNG emits 99% less sulfur dioxide, 91% less particulate matter pollution, and 20% less carbon dioxide. The main challenge of using LNG is storage. To stay a liquid, the gas has to be kept at a constant frigid temperature of minus 161 degrees Celsius. So this required engineers to build what is essentially the world's largest thermos. A gigantic 9-month construction project all on its own. So how big is this thermos? Its internal volume is so vast, you could fit 6 Olympic-sized swimming pools inside it. That's over 18,000 cubic meters, holding 20 million liters of LNG, enough for a journey from Asia all the way to Europe without ever refueling. All that fuel powers the largest natural gas-powered engine ever constructed. It stands 6 stories tall, weighs over 2,000 tons, and produces 85,000 horsepower. It is so massive that maintenance crews can actually walk around inside its components. So, with the hull assembled and the engine installed, the final critical steps begin. This is what transforms this immense steel structure into a vessel that's actually ready for the open ocean. The epic scale, it just extends to every single component. Take the anchor chain. Just one of its links weighs 300 kilograms. The entire chain itself weighs as much as 60 African elephants. After a year and a half of non-stop work, the ship is finally ready to meet the water. But first, it has to survive 15 days of intense sea trials, where every single system, from engine performance and navigation all the way to the emergency brakes, is pushed to its absolute limit. The successful completion of these trials, and ultimately the delivery of all 9 ships in record time, it represents more than just an engineering victory. It's a new benchmark. It's a testament to the skill and dedication of the thousands of workers who made it all possible. In the end, these megaships are more than just vessels. They are proof that if we decide to, we can move mountains of steel across the harshest seas and do it cleanly. It stands as a powerful statement about our ability to solve the biggest challenges, and it leaves us with one final thought. What impossible thing will we build next?